So we're going to draw that function, y equals x squared, x plus 1 squared minus 2, using the step pattern. We're going to fill in the table afterwards, right? But the step pattern should be enough for us to get this thing going. And then we're going to, after we get those coordinates, we're going to see how we can use the transformation concepts to create a table of values for the function f of x equals x over 3. So this is the original function now. My original function is not like I'm using the x squared function or the square root function or, no, my original function here is this function right now. Now we can talk about this as being a transform function itself, but that's the function that we're going to transform. We're going to transform the x plus 1 squared minus 2, and we're going to transform it by doing this. We're going to divide the x by 3 first before we add on the 1 and square it and then the minus 2. Start thinking about what that transformation should be. But let's first of all draw this function. So, can somebody remind me how we could draw that easily based on what we know about quadratic equations? Yes, the chair. It's in vertex form. So what would be the vertex? Let me fold this over now and grab my stylus out and get going here. It is in vertex form. And where exactly is the vertex? So Cherry, you want to tell us where the vertex is? -1, -2. Perfect. So what I'm going to do is I'm going to go ahead and put that on my chart. And in fact, since I know that that is one of the points on the graph, I'm going to put that in my table of values as well. All right? Is everybody clear on why the vertex is at, based on the vertex form? Is everybody clear on why -1, 2 is the vertex? Or -1, -2 is the vertex? Okay, perfect. So let's go ahead and do two things. I know, and I looked at your handout, and I know it's not very clear. The grid is not very clear. So just try your best, okay? But I'm going to put that point in the original, -1, -2. So -1, -2 should be somewhere about, let me just get the thing to open up here. Should be somewhere about here. Okay, so that's where my first dot is. So put that in for me, please. -1, -2. And how does it work now? How do we go from there to the other points that we need to put in based on the fact that we are at the vertex right now? We're right at the vertex. How do we do that? Yes, step pattern. So from there, we're going to go across 1 and up 1. As we're doing this, let's put the points in. So across 1 and up 1, across 1 and up 1 would take us right here and take us right here. I'm going to put those 2 points into my grid as well. So one would be 0, -1. And the other one would be -2, -1. Hopefully we can all agree on that. That makes sense. All right. I'm going from the vertex, up 1, across 1. Sorry, across 1, up 1. On both sides, right and left. Okay. Then I'm going to go across 1 again, but this time, as you heard from Shreyash, we're going to go up 3 now. Okay. And put that one on the graph as well. So across 1 and up 3. 1, 2, 3. Across 1 and up 1, 2, 3. So for my money, that looks like we're talking about 1, 2, across us 1, 2, 3. So that's -3. And we're up to 2, +2. And on the other side of that, it looks like we are at 1, 2. That's what I'm getting. You could double check that, make sure I'm getting that right, based on just simply using the points from the step pattern. Okay, so let's go again. We went across 1 and up 1. We went across 1 and up 3. Now we have to go across 1 and up 5. Good. So across 1 and up 5. So we're at 2 right now. That should take us up to 7 then. So across 1 and up to 7. Okay, so for my money, that looks like we're at 2, 7. And it looks like at minus 4, 7. That's what I'm seeing here. Just double check my step pattern. Across 1 up, 1 across 1 up, 1, 2, 3, across 1 and up, 1, 2, 3, 4, 5. Okay, are we all agreed on that? Can I just look at some of those graphs? My question is, and we're going to use Desmos to confirm this in a minute. My question is, what do you think is happening to that original function based on the one change that we made right here, which is why we divided the x by the 3? How would you describe that? Yes, Sarah. What's that? Tell me how. I agree, but tell me, describe it using transformation language. So the x is going to change, but how? Is it a translation? Is it a stretch? And what kind? Is it horizontal? Is it vertical? Yeah, give me some more meat on those bones now. You're right. You started off on the right track. A vertical compression? No, it's not. It's not. Anybody have another theory on that? You're started off right, but you're not quite there yet. Aaron, what do you want to tell us? Horizontal. Okay, you're half right. I'm not going to tell you which half. Yes, Charmaine. It's a horizontal stretch. It's a horizontal stretch. You're really taking the x and multiplying it by 1 over 3. Right? It's in disguise. I mean, it's not obvious. But because you're multiplying this by 1 over 3, think of this as being 1 over 3 times x. Because that's the same as x over 3. That 1 over 3, which you're multiplying by x before you do anything else, right? Before you add on the 1, before you square, before you do any of those things, that's what's causing you to have a not vertical, but horizontal. It's going to affect your x's, as you said. And it's not a stretch. Sorry, it is a stretch. It's not a compression. It's actually a stretch by a factor of 1 over whatever that a is. That a right now is 1 over 3. So the transformation that's taking place, so the transformation is a horizontal stretch by a factor of 3. It's a horizontal stretch by a factor of 3. Now, my question is, and Sarah was on the right track when she started off, what do I do with my coordinates to make that horizontal stretch happen? Right? What gets affected and how? If it's a horizontal stretch by a factor of 3, what do I do with my coordinates? Is it the x's that get affected? Is it the y's that get affected? I need to know. Which one? Okay, let's hear from the front of the room. Go ahead, please. You're right. And what do you do with the x's? If you multiply by 1 over 3, then you're making it compressed. Uh, clean that up for me, please. You're so close, but you're not quite. We said it was a horizontal stretch, which means it's supposed to get bigger. We said by a factor of 3, and you're right, it's going to affect the x's, okay? But I need you to nail it down for me now, please. I need you to nail it down. Come on, you're so close. All right? So, Sahil, come on, give it another shot. Not sure? Okay, I saw some hands going up. Yes, Yash. X's or Y's? Every X gets multiplied by 3. That's exactly right. Every X gets multiplied by 3. So Sarah started off on the right note. Aaron was kind of there when he said horizontal, but he got it as a compression. So, everybody is kind of dancing around it, but not quite there. You were on kind of the right track. So we're going to take everything. And what happens to the Y's? Stays the same. There you go. Stays the same. So we're going to go ahead and put the points in. So it's still -1. I'll use a different color. So it's still minus 1. Sorry, that's not the right one. It's still, I'll try this again. It's still minus 2 first. Then minus 1, then minus 1, and then 2 and 2, and 7 and 7. But each of the x's gets tripled. So that would be minus 3, still 0. This would be minus 6, minus 9, 3, positive 3, 6, and minus 12. Let me just check my math on this here. So minus 3, 0, minus 6, minus 9, 3, 6, and minus 12. Okay, perfect. Yes. No, if it was, well, when do the signs change? Can anybody remind me when it is that signs change? Go ahead. What's that? Well, there's a reflection. There's no reflection here, right? If this had been, let's say, minus x over 3, then I'd agree with you. But the signs are not changing because it's not a reflection. There's no reflection here. Yes. Once. Oh, actually, he had his hand up first. Sorry. Okay. What are you? Okay, so here's the original function. X plus 1 squared minus 2. That's the original function. Are you doing something to the whole function or just to the x? And that's how you know that is horizontal, first of all. What are you doing to the x? You're dividing it by 3 or multiplying by 1/3. The inverse or the reciprocal of dividing by 3 is multiplication by 3. But horizontally, always make it go backwards. So that's why it's a horizontal stretch by a factor of 3. So let's go ahead, put those points, and I'm color coding mine on my grid. So minus 3, minus 2. And each of these, just so we know, each of these is the image of the other. So this point, minus 1, minus 2, became minus 3, minus 2. 0, minus 1 stays where it is. It's invariant. Minus 2, minus 1 becomes minus 6, minus 1, and so on. I'm going to go ahead and draw mine. Then we're going to go to Desmos, and let's Desmos sort of show us that what we did is right. Okay, Desmos is going to prove to us that what we did is right. So here we go. Here come my points. Minus 3, and what's happening is that every single x value is getting pushed along the horizontal line that it's on 3 times as far away. Okay? So minus 3 minus 2 would be somewhere around here. 0 minus 1 does not change. 6 minus 1, or sorry, minus 6 minus 1 should be somewhere around here. Minus 9, 2. Minus 9, 2 would be about here. 3, 2 would be about here. 6, 7 would be about there. And minus 12, 7 would be about here. Okay. I'd like to see everybody put those two together for me now. All right. Just put the points on. Did I put arrows on there before? Okay, good. Arrows are there. So put those points on and draw your line through the points. And then we're going to see if this matches up with what Desmos says it would have been. Okay? This is the last one that we're going to be doing. It says 2, and this is a square root function this time. So these table values are no longer x squared. You were asking earlier on, somebody was asking earlier on for the x squared. This is the general format for the transformations. Now we're being specific as to which function it applies to. We're going to do this for the square root of x function. So my question now is, what is a list of transformations? Now there's some that are obvious and some that are not so obvious, and you have to be careful again. All right, I'm telling you again, you have to be careful again. All right, so I like the fact that you're being brave and stepping up. Let me hear what you got, Sahil. Is there a reflection on the y-axis? Is there a reflection on the y-axis? There is. Good. That's because of the negative in front of the x. Yes. So I'm going to write that down. Even though there's something that we need to be doing before we get to all of that, I'm going to write it down anyway. So reflection on the y-axis. Reflection on y. What else do you see there, folks? Sana? A vertical stretch by a factor of 2, you said? Absolutely. I agree. Vertical stretch BAFO of 2. Completely agree with that. What else? Triash? VT down 3. I agree. What else? Yes. Somebody is thinking here. We should really rewrite this as the following. 2f of minus, I should put a square bracket here, x plus 5, and then the minus 3 on the outside. I'm factoring out a minus 1. This is the same thing as minus x minus 5. That's the same as minus x minus 5, but factoring out that minus 1 first now makes it obvious that what we have, apart from the reflection on the y, which I agree with, still agree with that, what else is happening here? You want to tell them? It's a horizontal translation to the left by 5. HT left by 5. That's exactly correct. Yes?
If you knew what Manahal said, how would you have found that 5? Because then it would have been right for the 5. No?
Yeah, but you have to factor out. Anything that's in front of the x has to be factored out. Anything apart from 1, that is. And this was a minus 1, so we factor out the minus 1. Okay? So we had to do what Manahil just said. Yes, Anna? You get it wrong. Right? You'd absolutely get it wrong. You'd probably think it was to the other direction, and it's not. Okay? So this is actually being shifted to the left by 5. Absolutely being shifted to the left by 5. We'll see that in a minute. Okay. Now, we know by now what affects the x and what affects the y. Hopefully we do. Let me talk to AJ about that. AJ, reflection on the y. What is that affecting? Let me get a different color here. Oh, my colors are whatever. What is that affecting? The reflection on the y. Does it affect the x or the y? Reflection on the y affects the, what's that? Affects the x. That's correct. It affects the x. So where do I put that now? Let me put that in. Can I change the color here? Hopefully I can. So this affects the x. Oh, it does work. Okay, perfect. The vertical stretch by